Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 2 to the power of m plus 4 to the power of m plus a to the power of m is equals to 39, and we solve this problem for all the values of m. Here we get all roots of this equation, and now first we rewrite this equation as this will be written as 2 to the power of m plus we write this 4 as 2 square and its whole power m plus we write 8 as 2 cubed and its whole power m is equals to 39. And now further in the next step, here we interchange both of these two exponents and we get 2 to the power of m plus. This will becomes 2 to the power of m and its whole square plus. Here again we interchange both of these two roots and we get 2 to the power of m and its whole cubed is equals to 39. And now here we will just take the base of this term is equals to y, and we get y is equals to 2 to the power of m. So we put this value of y to the above equation, and this will be written as y plus y square plus y cubed, and this is equals to 39. And now in the next step we have y plus y square plus y cubed is equals to, this is 39, and we write it as 27 plus 9 plus 3. So we rewrite this equation as y plus y square plus y cubed is equals to, we write this 27 as 3 cubed, we write this 9 as 3 square, and this is our 3. And now we move all the terms from right hand side to the left hand side, and we make the cubic term with, we make the pair of cubic term with cubic term, square term with square term, and vice versa. So we get here, this is y positive 3 becomes negative 3 plus, this is y square, we get y square minus 3 square and plus y cubed minus 3 cubed, and this whole equation is equals to 0. And here we use the nice algebraic formulas. You know about that. If we have a square minus b square equals to a minus b times of a plus b, and second we use this cubic formula, a cube minus b cube equals to a minus b times of a square plus ab plus b square. So we use both of these two formulas to the above equation, and this will be written as y minus 3 times plus, here we use this formula and it will becomes y minus 3 times of y plus 3, and we write this term as y minus 3 times of y square plus y times of 3 plus 3 square, and this whole equation is equals to 0. And now you see that each of these terms involve y minus 3. So we take common y minus 3 from here and we get the remaining values are, from here we get 1 plus, from here we get y plus 3, and from here we get y square plus 3y plus 9, and this whole equation is equals to 0. And now in the next step we rewrite this equation as y minus 3 times, this will becomes y square plus 3y plus y becomes 4y, 9 plus 3 plus 1 becomes 13, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write y minus 3 is equals to 0, and the second case is we write y square plus 4y plus 13 is equals to 0. From here we get the value of y is equals to plus 3. This is the first root of the given equation. And from here we get the other roots. For this we use the quadratic formula, and first we write the coefficients of this equation, and its coefficients are a is equals to 1, b equals to 4, and c is equals to 13. And we state the quadratic formula as y equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So here we substitute all the values of a, b and c, and we get y is equals to, this is minus b becomes minus 4 plus minus square root of 4 square minus 4 times of a is 1 and c is 13, and it is divided by 2 times of a, and here our a is equals to 1. So we need more simplifications, and we get y is equals to minus 4 plus minus square root of 4 square becomes 16, and 4 times of 13 becomes 52, and it is divided by 2 times of 1 is equals to 2. And now in the next step we need more simplifications here, and we get y is equals to minus 4 plus minus square root of 16 minus 52 becomes minus 36, and it is divided by 2. So we rewrite this equation as minus 4 plus minus, we apply square root separately on both of these two values, and we get square root of 36 into square root of minus 1, and it is divided by 2. And further we have y is equals to minus 4 plus minus, we know that square root of 36 becomes 6, and square root of minus 1 is equals to iota. And here we break this fraction and we write these two separately on both of these two values. And now in the next step we have y is equals to, this is 2 times 2 becomes 4, and we get minus 2 plus minus, this is 2 times 3 becomes 6, and we get 3 times of iota. So these are the other two complex roots of the given equation. So here we get these are the three values of y, and now we need to move backward and we put the value of y here. And in the start of the problem we will take y is equals to 2 to the power of m. So we put this on both of the sides and we get 2 to the power of m is equals to minus 2 plus minus 3 times of iota, and in this case we have 2 to the power of m is equals to 3. So here we apply the log on both the sides to get the value of m, and we get a log of 2 to the power of m is equals to log of minus 2 plus minus 3 iota. So here we move this m in the front of this log, and we get m times of log 2 is equals to, this is log of minus 2 plus minus 3 iota. So here we divide log 2 to the right hand side, and we get m is equals to log of minus 2 plus minus 3 iota divided by log of 2. So here you see that we use the property of log and we write it as log of log with base 2 into minus 2 plus minus 3 iota. So these are the two complex roots of the given equation. And now in the same pattern we get the other roots from here, and here we again use log on both of the sides, and we get log of 2 to the power of m is equals to log of 3. So we move m in the front of this log and we get m times of log 2 is equals to log of 3. So we move log 2 to the right hand side and we get log of 3 divided by log of 2, and we rewrite this term as log of 3 with base 2. So this is the third value of m, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.